Bonsuelo, mathletes! It's the beginning of another great semester. I hope you're really looking forward to it. I know that I am. What are we going to start talking about in Chapter 5? Chapter 5 is on something called polynomials. But before we get to the polynomials, you first have to understand exponents. So what we're going to talk about today are the exponent rules. And then we'll get to polynomials another day. Okay, the first thing I want to mention about the exponent rules is the most important thing to know is not the exponent rules. I'm not saying they're not important. Of course they are. But quite frankly, what the most important thing you need to know is not the rules themselves, even though you need to know them. It's this idea right in front of you here that in order to combine anything, something, either the exponents or the bases. Now, let me just mention something real quick. I'm going to write something on the board here, but don't write it. Okay, the 5 is the base and the 2 is the exponent. So something, either the bases or the exponents have to be the same. Whatever's the same, okay, you don't touch it. Do not do anything to it. It's got to stay the way it is. What you combine is whatever is not the same. So let's take a look at 4 examples, and hopefully I'll make this clear. The first one, 2 to the 5th times 2 to the 7th. Okay, what's the same here? The bases are the same. So the 2 stays a 2, and then the 5 and the 7 combine, you add them, and we'll get to the exponent rules in a second. But you add them, and that'll give you 12. So we get 2 to the 12th power. On number 2, the exponents are the same. So I'm not going to do anything to the exponents. What I'm going to do is I'm going to combine the bases, and you just combine them as you'd normally combine them. So 5 times 7 is 35, and then the exponent stays the same. Okay, number 3, nothing's the same. So you can't combine them as they're written. Now, eventually we can combine them, but as they're written, you can't combine them. But what we can do is say 2 to the 3rd is 8. 5 squared is 25. Now I can combine them, and that'll give us 200. Okay, last one, number 4. A lot of people say both the bases and the exponents are the same. Can't be. And I know I'm being kind of picky here, but that's the way you have to look at it, okay? The exponents and the bases can't be the same. Or let's put it this way, you can't think of them as being the same. You have to choose, are the exponents the same or are the bases the same? And it doesn't really matter which one you pick, but let's just say the exponents are the same. Okay, if the exponents are the same, then you're going to combine the bases and call this 4 to the 3rd power. So the exponent stays the same, you combine the bases. Right, now what if the bases are the same? You leave the base alone and you combine the exponents, and that gives you 2 to the 6th. And they're the same thing, 4 to the 3rd and 2 to the 6th, because both of them are 64. Okay, so the point I'm trying to make is pick, on this last one, pick what you want to be the same. It doesn't matter which one it is, and then just, you don't change that one, you combine the other ones. Okay, now at this point I kind of have to mention something. Look at your answers to these 4 problems. 2 to the 12th, 35 to the 3rd, 200, and 64. Now notice in the last one, I had 4 to the 3rd and 2 to the 6th, but I didn't leave it that way. I called it 64. Well, how about on the first one, 2 to the 12th, I just left it. The second one, 35 to the 3rd, I just left it. All right. So the question's going to be, and someone's going to ask this, and it's a good question, how do you know whether you can leave it written in the exponential form or whether you actually have to multiply it out? In other words, like on number 4, how do you know that you have to call it 64 instead of 4 to the 3rd or 2 to the 6th? Okay, this is the way I'd put it to you. And this isn't like a real hard and fast rule, but if you can conveniently, relatively easily multiply it out, you should. So for instance, I'm going to scribble some stuff down here on the bottom, okay? 2 squared, you should know that's 4. 2 to the 3rd, you should know that's 8. 2 to the 4th, you should know that's 16. 2 to the 5th, you should know that's 32. 2 to the 6th, you should know that's 64. Okay, at this point, we're kind of getting marginal. Okay, 2 to the 7th is 128. If you leave it 2 to the 7th, I'd probably be okay with that. Okay? But certainly, up through 2 to the 6th, you should be able to tell me what that is. That should be no problem. Okay, well, does that mean as long as the exponent's, 6 or lower, you have to Show it to me. Well, no, not really. It's like just use common sense. You should be able to do relatively simple ones. 3 to the second's 9, 3 to the third's 27, 3 to the fourth is 81. Okay, 3 to the fifth is 243, but that's kind of marginal. So probably about 3 to the fourth. Notice the bigger the base, kind of the smaller the exponent I'll accept. Okay, well, how about like 7? Okay, 7 squared, 49. 7 to the third, who knows? I don't even know what that is. Okay, so look at it, and if it's reasonable, yes, you should multiply it out. Now, you can say, well, but what if, you as the student don't think it's reasonable, but Mr. Leblanc, he thinks it's reasonable, and he's going to mark off. Okay, it's really pretty simple. Let's say you leave 3 to the fourth as 3 to the fourth instead of calling it 81. All right? I just look at your other problems. If you leave something 2 to the third instead of calling it 8, I'll take off for that, and I'll take off for the 3 to the fourth. Okay, but if you're calling 2 to the third 8, and you're calling 2 to the fourth 16, and you're calling 3 cubed 27, and then you leave 3 to the fourth, okay, I understand. It's, you're probably just thinking it's marginal, and that's fine. I'll accept that. But if you just leave everything with an exponent, no, I'm going to just start taking off. Okay? All right, so let's take a look at the exponent rules. And first of all, I've already explained negative exponent rules. Remember that negative exponents are not negative numbers. This was back at the beginning of the year. A negative exponent merely moves the value from numerator to denominator or vice versa. Okay, so the first rule here, if you multiply, you add the exponents. If you divide, you subtract the exponents. If you raise to a power, you multiply the exponents. And then may you distribute an exponent? Well, as long as there's not a plus or minus, and I've kind of told you this before too, yes, you may. So if this one, again, I'm going to write something down. Don't do it. No, you write it. If this was a plus, no, you couldn't distribute the exponent. Okay? But as long as they're, multiplied or divided or something like that, go ahead, distribute the exponent. And also, anything to the 0 power is 1. Okay, so let's just take a look at some problems. All right. And, like on this first one, I would just expect you to tell me it's x to the 10th. I don't need to show you to show me that 2 plus 8 is 10. Okay, on the second one, you really wouldn't need any work on this one either. I'm going to do it, but we have x as the base, and we take 8 minus 2, which is x to the 6th. But you wouldn't need to show me any work there. Okay, now let me show you something on number 3. First of all, this is people that follow the rule exactly as it's written, that you subtract the numerator exponent minus the denominator exponent. They usually do this. Don't write this down because this is not a good way to do it. It's correct, just not a good way to do it. They go 2 minus 8 and x to the negative 6th, and then a negative exponent puts it in the denominator. Perfectly correct. I don't know why you do it that way, but all you do is this. Okay, you take the larger exponent minus the smaller exponent, and you put it wherever the larger one is. So again, you wouldn't have to show me any work here, but it's this. It'd be x to the 8 minus 2 power, but I put it in the denominator since the larger exponent's in the denominator, which is 1 over x to the 6th. And again, you could just go straight to that. Okay, the reason why I like number 4 here is because it makes you realize that you treat exponents differently than you treat just regular numbers. See, the 4 and the 20 cancel to give you 5, okay? And the x to the 20th and the x to the 4th do cancel also, but it doesn't give you x to the 5th. It gives you x to the 16th because you take 20 minus 4 with the exponents. Okay, on the next one, here's what most people do. Don't write this down because this is wrong. They say 2, x to the 35th, y to the 50th. Okay, now what's wrong with that? If I give you this, don't write it down, just watch. x to the third, y to the seventh, z to the 10th, all raised to the 7th power. How many things do you have to distribute that 7 to, the exponent 7? Well, you have to give it to 3 things. There's the x to the third, the y to the 7th, and the z to the 10th. Well, okay. In which case, let's go back to the problem we're looking at right now. How many things do you have to give the exponent of 5 to? Well, there aren't just 2 things, there are 3 things. There's the 2, the x to the 7th, and the y to the 10th, and a lot of people forget the 2. Okay, so this is 2 to the 5th. Now you can write it down. X to the 35th, because the exponent here is understood to be 1, so 5 times 1 is 5. Then x to the 35th, y to the 50th, and yes, you must call 2 to the 5th 32. So it's 32, x to the 35th, y to the 50th. Okay, anything to the 0 power is 1. You don't need any work for that. May you take this 0 exponent and distribute it? No, you may not. Why not? Because of these plus signs. Okay, and you wouldn't get the same thing. You'd end up getting a different answer, which I'm not going to go into. But just anything to the 0 power is 1, no matter how complicated it looks. Okay. As a matter of fact, that's one thing I'm going to try and get across eventually, that no matter how complicated the problem looks, the answers don't vary. Okay, the method you use to get the answer doesn't vary. Okay, let me show you here what a lot of people do. Number 7, don't write this down. They say, okay, it's x to the 6th, and x to the negative 2nd is 1 over x to the 2nd, which is not wrong, but it's just more complicated than you need to do. All you should do, remember, what does a negative exponent do? It takes something, it moves it from the numerator to denominator or vice versa. So x to the 6th stays there, and x to the 2nd goes to the top, and you get x to the 8th. That's the way I would do it. I don't try and combine things that have negative exponents. There's one case where I will, which I'll get to in a little bit. But, what a lot of people will do is they'll say x to the 6th, don't write this down, 1 over x squared, and then you have x to the 6th times the reciprocal of 1 over x squared, and that's all correct. But why go through all that? Okay? Another thing people do, which is not wrong, but I really would not recommend it, is they say 6 minus a negative 2. Perfectly correct, and that gives you x to the 8th. I still wouldn't do it. People that deal with negative exponents, like I say, there's one exception where I will deal with negative exponents, but for the most part, I don't. I just get rid of the negative exponent and then I deal with the problem. Again, I wouldn't call this, don't write this down, but I wouldn't call this 1 over x to the 6th over x squared and then finish the problem off. You could, you're just making it harder. All you do is you take the one with the negative exponent, and right now it's in the numerator, so you move it to the denominator. And then you worry about combining them. Okay? Number 9, this is where people will really get messed up if they're actually trying to combine these things with negative exponents, et cetera, et cetera. Okay, the one in the numerator goes to the denominator, and the one in the denominator goes to the numerator. And now you just, subtract the larger one from the smaller one, and you get 1 over x to the 4th. Okay? All right, here. We have 2 to the negative 3rd goes into the denominator, which is 1/8. And you could skip that middle step there. If you just want to go straight to calling it 1/8, that's fine. Okay, notice it's not a negative number. Number 11 is a negative number. So we have negative 8, because 2 to the 3rd is 8. And 12 is both a negative number and has a negative exponent, so it's 2 to the 3rd goes to the bottom, and we have negative 1/8. Okay, I don't care how bizarre it looks. What does a negative exponent do? It just moves it to the bottom. And you don't know how to deal with that right now, so you don't have to. You just take the whole thing and you just move it to the bottom. Again, what I would do here is I would not try and deal with a negative exponent. Don't think of a negative exponent as flipping something over. Yeah, I realize that technically maybe that's correct, but I would just give the negative exponent to each one. By the way, this is the one time when I'll deal with negative exponents. When there's a negative exponent outside of a parentheses, I'll deal with that first. So notice how I gave each one the negative exponent. And then I'll flip them. No, I'm not going to flip them. The one in the numerator goes to the denominator. The one in the denominator goes to the numerator. And then that'll be 81 over 49. And you could skip this middle step and go straight to that. Okay, here. Again, this is the one time when I'll deal with a negative exponent. The first thing I'll do is give the negative exponent to each one. All three of them. The 2, the x to the 5th, and the y to the negative 7th. So we have 2 to the negative 3rd, x to the negative 15th, and y to the 21st. Now, anyone that has a negative exponent, I'll change its position. So the 2 to the 3rd goes to the bottom, which is 8. The x to the 15th goes to the bottom, and the y to the 21st stays on top. Okay. There are two operations here. There's the exponent, and also there's multiplication. The negative 3 does not go to the 7. It only goes to the x. So the 7 stays in the numerator, and the x to the 3rd goes to the denominator. Now in number 17, the negative 4 goes to both of them, since it's in parentheses, since the 2x is in parentheses. So I'm going to give the negative 4 to each one. And now everyone that has a negative exponent, I'm going to change its position. So we have 2 to the 4th on the bottom, which is 16, and x to the 4th. Okay, again, I'm going to give the exponent to each one. So you just have x squared, y squared. That's all there is to it. Whereas in 19, you can't do that because of the plus sign. So you actually have to take x plus 2, x plus y times x plus y. And then again, it's just the distributive property. So it's x squared plus 2xy plus y squared. Okay, here you do the exponents first, and then you do the multiplication. So we have 7 squared, x to the 10th, y to the 6th, and x to the 56th, y to the 32nd. Now I'll combine what I can. The 7 squared becomes 49. The x to the 10th and x to the 56th becomes x to the 66th. And the y to the 6th and the y to the 32nd, you add those and it becomes y to the 38th. 21's the same deal. I'm going to give the exponent inside the parentheses first. So you end up with 7 squared, x to the 10th, y to the 6th, all over, x to the 56th, y to the 32nd. Now, the 7 squared is going to stay on top. And again, I'll subtract the larger exponent minus the smaller exponent and put it where the largest exponent is. So 56 minus 10 is 46, and that's going to go to the bottom. And 32 minus 6 is also going to go to the bottom. Okay, getting progressively more difficult here, but you know what? The rules don't change. I don't care how bizarre it looks. Okay, first of all, the thing I want to say about 22 is don't try and deal with, again, when I have a negative exponent outside a set of parentheses, the first thing I do, if I'm allowed to, is give the negative exponent to each one. So like, I'm not going to try and deal with the negatives yet and flip the position, stuff like that. Okay, so we have 2 to the negative 2nd. X, negative 7 times negative 2 is 14. Negative 1 times negative 2 is 2. Negative 3 times negative 2 is 6. And then on the bottom, we have 10 to the negative second, x to the negative second, y to the 16th, and z to the 10th. Okay, now I'm going to just change the position of anyone that is a negative exponent. So the 2 to the negative second goes on the bottom. That's a 4. The x to the 14th stays. Y squared stays. Z to the 6 stays. X to the negative second goes to the top. Sorry, the 10 to the negative second goes to the top. So that's 100 on top. The x to the negative second goes to the top. And the y to the 16th stays where it is. And the z to the 10th stays where it is. Now, I'm a little short on room here, so I'm going to put the final answer right here. Okay? So, the 4 and the 4 and the 100 cancel to give you 25. The x's combined to give you x to the 16th. Because 14 plus 2 is 16. X to the 14th and x squared. The y's cancel, and 16 minus 2 is y to the 14th on the bottom. And the z's cancel, and you get 10 minus 6 is z to the 4th. Z to the 10th and z to the 6th cancel. 10 minus 6 gives you 4 on the bottom. Okay. Number 23, the only thing that happens is this is going to move to the top. So it's negative x to the third over 4. That's it. Just move the negative third to the top. Okay, on 24, I'm going to give the negative 3 exponent to each factor that's in the parentheses. Notice on 22, the whole fraction was in the parentheses. On 24, only the top is. So this is 5 to the third, negative third, x to the 24th, and y to the negative 21st. All over x to the negative 5th, y to the negative 10th. Now, anything that's negative exponent, I'm going to move. So the 5 to the third goes to the bottom. That's 125. And yes, I expect you to call it 125. The x to the 24th stays on top. The y to the 21st goes to the bottom. Now on the bottom, the x to the negative 5th goes to the top, and the y to the 10th goes to the top. And now I'll just combine whatever I can combine. Okay, the x's become x to the 29th. And then on the bottom, you have 125, and y to the 10th and y to the 21st cancel to give us y to the 11th. Okay, thing I want to get across with these last three is that no matter how bizarre the problem looks, the rules don't change. Okay, first of all, there's multiplication, and then there's also an exponent. I do the exponent first. Now, what do you do when you raise an exponent to a power? Like here, don't write this down, but what's t to the 5th raised to the 7th? You'd multiply 5 and 7, okay? Well, you're going to do the same thing here. First of all, this is going to not change at all, the first thing. So that's t to the x plus 2. But I'm going to multiply the x plus 7 and the 2 and get t to the 2x minus 14 power. Okay? Now what do you do when you multiply? Don't write this down. T to the 5th times t to the 7th. I'm going to add the 5 and the 7. So I'm going to do the same thing here. I'm going to add, and I'm going to write a step you wouldn't need to write. You don't need to write this. I'm going to add the x plus 2 to the 2x minus 14. And that'll give us t to the 3x minus 12 power. Again, I don't care how bizarre it looks. You just do the same thing. Okay, here what do? We're going to multiply first. So I multiply the half and the 1/3. And if you multiply a half and a 1/3, you get 1/6. Now, when you multiply, what do? You add the exponents. So I'm going to add 1/6 and 4/5. But to do that, I need a common denominator. So this will be 5/30, because 1/6 is 5/30, plus 24/30. And why is that? Because the common denominator is 30, so you multiply top and bottom by 5/5 on the first fraction and by 6/6 on the second fraction. It's just adding fractions. And then we combine them and get x to the 29/30. Okay, number 27. We're going to add the half and the third and subtract the 1/5. Rule's the same, it hasn't changed. So we get the common denominator of 30. So this is 15/30 plus 10/30 minus 6/30. And that'll be x to the 19/30. Okay. Again, the main thing I want to emphasize is that something has to be the same. And whatever's the same, you don't change it. You keep it the same. You combine the things that are not the same. Okay? And then the bottom here, 25, 26, and 27, no matter how bizarre the problem looks, you do the same thing. It doesn't matter. It's like saying this. If you have x, if you take a look at 27, let's say I give you this problem, x to the dog power times x to the cat power all over x to the snard power. Okay, what would that be? That would be x to the dog plus cat minus snard power. Why? Because when you multiply, you add, and when you divide, you subtract. Okay? Little bonus problem there. We'll call that number 28. Okay. Exponents. Okay? Get used to them. If you have any questions, ask me, but we're going to be using those quite a bit for the second semester. So if you have any questions on them, please let me know. All right. Have a good day, everybody. Bye-bye.